So 3.5.3 Trigonometric Graphs. 5.3 graphs. So last time I talked about the graphs in general for trigonometric, and I start talking about how to graph for the function, the sine, and for the sine function. But for the cosine, I'm going to do it today. Yeah, for the quiz, we're going to do it in the last, in the end of the class. Yeah, it's today. The quiz is today at 9:40. I mean, the quiz is today at 9:40. So first of all, we have to know the function sine and cosine have a period too. So the functions, it's a periodic function. The function sine and cosine is a periodic function, so they have period 2 pi. What does that mean? Like, I mean, the sine function, sine of t plus 2 pi is exactly like the same like sine of t. And the same things for the cosine function. Cosine of t plus 2 pi is the same as cosine t. This means it's repeating their values after like 2 pi. Also, I start graphing the sine function. I give the table t and terminal point, and the sine of t and the cosine of t. So I start from t equal from 0 to pi over 2, and from pi over 2 to pi, from pi to 3 pi over 2, and 3 pi over 2 to 2 pi. So here t, so make a table. So the terminal point for the point 0 is 1, 0 goes to, the terminal point for pi over 2 is 0, 1. The terminal point for pi over 2 is 0 and 1. This is from the previous section. The terminal point for pi is -1, 0. The same thing is here, -1, 0 goes to 0 and 1. And here from 0, 1, -1 goes to, here -1, sorry, goes to 1 and 0. And I said the sign for t, this is mean the y value for the coordinate, the y value for the terminal point. So the y value is 0 here, and the y value is 1. So from 0 to 1, and here 1 to 0. Same things here from 0 to -1, and from -1 to 0. The y coordinate for the terminal point. But for the cosine t, it's the x coordinate for the terminal point from 1 to 0, and from 0 to -1, and from -1 to 0, and from 0 to 1. Now I can graph. So the graph this is my x values and this is my y values for the sine, and the same things for the cosine. So let me start graphing. So here is my unit circle. This is my unit circle here. So this is my unit circle. So the unit circle divided to the 4th pieces. Now this is my y-axis and this is my x-axis. So first of all, we have to know, like from the table before here, from t equals 0 to pi over 2, t is the distance, by the way, the distance on the unit circle, okay? T is the distance. So distance from 0 is, so the t is 0 at 0 is here, and the t at pi over 2 is here. This is the t of pi over 2. So I'm working from this on the unit circle, working in the unit circle like this, okay? So working in the unit circle like this, from 0 to pi over 2. So the values for the sine is from 0 to 1. So by the way, here the value is 0. It is pi over 2. This is pi. This is 3 pi over 2. And here is 2 pi. Okay. And this is the value for t, and here is the value for the y equals sine of t. So the value is between 1 and here -1. Okay. So from t equals 0 to pi over 2, the sine function goes from 0 to 1. So from 0 here, from 0 to pi over 2, the sine goes from 0 to 1 in this interval. So I can make it like from 0 to pi, it will be like something like this. This is the first one. Now for the second part, if from pi over 2 to pi, so the graph will be like this. From the table, from pi over 2 to pi is from 1 to 0. So 1 to 0 will be like this. This is the value for 1. This is the value for 0, goes down like this. Third one is from pi to 3 pi over 2. This is here pi, here 3 pi over 2. So the graph will be goes down. And the last one is from 3 pi over 2 to 2 pi, the graph will go up to 0. How I know? From the table before, all this from the table. And this is the period, the distance here, the distance is 2 pi. Distance from here, this point until this point, from here to here, is the period. It's 2 pi. So this is mean I can continue here. The graph will be like this. The same things from this side, I can continue because it's periodic function. But I'm going to use also the value from here. Most of the time, most of my graph will be from 0 to 2 pi. The same things for the cosine. This is the sine function, sine of t. Now the cosine, the same things. I'm going to graph it, the same steps. The graph will be from 0 to pi over 2 will be, by using the table before, So again here pi over 2 pi, 3 pi over 2, 2 pi. So here pi over 2, this is pi, 3 pi over 2, here 2 pi. So the graph will be here 1, and here is -1. The graph like this, at the red from 0 to pi, be down like this. Then the yellow from pi over 2 to pi be like going down, this. Then the orange go up. Then the blue go up again, like this. So this is the graph of the cosine function, y equal cosine of t. This is for cosine. I can continue because it's a periodic, like I said. So I can continue like this. The graph would be like that. Same things here from this side. You go up. Okay, so the graph of the cosine function is this things, this one, and the graph for the sine is this one. Any question? So this is like a graphing for a sine and cosine function. Now, we're going to graph by using the transportation. So this is by using the table. So now we know how is the graph for the sine function is this one. The graph for the cosine is this one. And the same period from here to here is 2 pi. From here to here is 2 pi. So this work for this one, and the circle work for this, for both the graphs. Now, a graph by transformation. Graph by transformation. So I'm going to give you example how to graph. Example is sketch the graph for a f of x equal 2 plus cosine, b graph g of x equal minus cosine x. Who will give me the idea for the first one? How can I graph f of x? How can I graph the first one?
Isn't it just going to move up by 2 units?
Yes. So we're moving up 2 units. But which graph for which function?
Cosine x, so x equals 0, value is now going to be 3.
Yes, exactly. So first of all, for graph this one, we have to graph the original function is the cosine function. Like the cosine function is given by this. This is the graph for the cosine function. At 0 is 1, same things here. So this is the graph for the cosine function. So here has something like this. I'm just going to use only period 2 pi. This value is 1. This value here is -1. This value here is pi over 2. And this value is pi. Here is pi over 3, and this value here is 2 pi. Now, plus 2, so we graph here, the original function is cosine function, cosine x. Now, the graph for 2 plus cosine, we have to shift everything up. shifting this graph up. So I'm going to shift first of all the x-axis 2 units. So this value is 0. So shift it up 2 units will be like 2 around here. Like around here. So this shifting the x-axis, this the x-axis, we shifted 2 units. The first unit is 1, the second unit is 2. So this is my x-axis. But is not the x-axis, I mean like shifting this line 2 units. So here be like this. It's not like a straight line. It's not a straight line. But this is just to help you how to graph the function. Like this. It's not a straight line. Okay, so this is the x-axis. I shifted 2 units up, and this value here is 2. This value here is 0. Now we shift this point is 2 units, so from 1 to 3. So this value becomes 3. So 1 becomes 3. But minus 1 at 2 units become 1. So this value become 1. So here, come like this, down, then up. This 3, this is 1, this is actually 1, close to 1. Now it's good. So this 1 here, 3, 1, and this point also 3. This point is 2 pi, 3 pi over 2. And here, yeah. So this is the graph of 2 plus cosine x. Shift everything 2 units up. For the second one, who will do the second one? G of x minus g of x. Who will give me the idea how to do the second one? Minus cosine x.
Do we flip it?
We flip it around which axis?
The x-axis.
X-axis. So we like it's not flip, is like reflect. So we reflect the cosine function around the x-axis. So this is the graph of f of x here. I'm going to do the g of x in the same graph. So for the second one, this is the first one here, number 1. For the second one, we reflect because the minus outside the function, so we reflect it around the x-axis. So my mirror is the x-axis. So the 1 become minus 1. The 1 become minus 1. This point stay the same. This point reflect up, down, and this point here. So the graph would be something like this. Up, it's not nice. So this is the graph for minus cosine function. So this is minus cosine of x, the blue one. So this is number 2. Any question? Any question? X, I mean the t-axis. This is t. Okay, so this is what you have to know about how to graph by transformation by using the previous section. Now, now let's go over the shifting. How can we do shift for the sine and the cosine curve? So here, shifting the function. So to do shift for the sine and cosine curve, the sine and cosine curve is given like y equal a times sine k open parentheses x minus b, and the same things for the cosine function. So first things we have to know the amplitude. It's the absolute value for a. This a, I mean. The absolute value for a is called the amplitude. The period is 2 pi over k. I'm going to write it down. So it is 2 pi. Here the 2 pi. This is 2 pi here. Divided by this k. This k. The horizontal shift is b, this b. One complete period is the open interval from b, comma, b plus 2 pi over k, the period. So again, a sine, this is k. This is my k here. This is k. 2 pi over k. The period is the absolute value for a, the amplitude. The absolute value for a, this a, I mean. This a, this a, this a here. And the one complete period is the b, from b, comma, b plus 2 pi over k, the period. Any question for these things here? Is it clear? Is it clear here, the sine and the cosine curve? What is the meaning of amplitude, period? So I'm going to give you a case if it's clear. Suppose my b here is 0. So in case b equals 0, if b equals 0, this b, so now the y equal a sine times k times x, and the other curve is y equal a cosine k times x. So the amplitude is the same, the absolute value for a. Number 2, the period is the same thing, 2 pi over k. We don't have any horizontal shifting, no horizontal shifting. For number 3, we have complete period, the period complete one, complete period is starting from the 0, comma, plus 2 by k, 2 by k over k. This is the difference between if b equals 0, this b, or b is not equal 0. Any question? Here, number 2, 3, 4. Okay, I'm going to give example for this. What is k? Okay, I get a question here. What's k? K is a number greater than 0. It's a real number greater than 0. So k, here I can set k is number greater than 0. It's not 0 because if 0, the cosine of 0 is 0. Constant, yes, X is a number. K is number, is a constant. Greater than 0, number greater than 0. X is variable. B is number. B, K, and A, all of them numbers. The only one is not numbers is X. X is a variable. Okay, now let me give you an example. Like the question is a graph. It's not a graph. It's find the amplitude, period, horizontal shifting, and one complete. Here. So the question is find the amplitude, period, and horizontal shift and the graph one complete period for. The question is 1 y equal 4 cosine 3x. What is the amplitude?
4.
4. How you find it? Can you give the steps or tell me how you find it?
It multiplies the entire cosine function. It's not inside the cosine function.
It's the amplitude is, look,
Right.
the absolute for a. That's true. So here the amplitude, let me use different color, red. Amplitude is the absolute value for 4. So if this minus 4, they give me 4. Taking the positive only. Absolute value for 4. That's true, Angel. Now, what is the period?
6 pi.
6 pi. So use this formula. Period is 2 pi over k. What is k? So first of all, you have to write this one as like this. Y equal a cosine kx. So the period, if you go back, the period is 2 pi over k. So this is equal 2 pi over k. What is k here in the equation? Is 3. So 2 pi over 3. So this is the period. Okay. And horizontal shift. As we said here, if p equals 0, no horizontal shift. Why? Because the curve does not have any horizontal shift. The horizontal shift if p not equal 0, like this steps here. So here be no horizontal shift. Now, what's the complete period? One complete period here. The one complete period is from 0, comma, the period 2 pi over k. So the third one is one complete is from 0, comma, 2 pi over 3. This is complete period. I mean complete period like from here to here. This is called, I mean like from here to here. Or from here to here. This is one complete period. This is one complete period. The one complete period is from 0 to 2 pi over 3. Now, how can I graph it? Look, how can I graph? It's simple. First of all, you go to graph like the cosine function. This is the cosine function here. The cosine function has a graph like this. Like this. At 1, like this, goes down, then goes up. This is the cosine function. This is the first step. Now, by using these steps 1, 2, 3, 4, you can graph it. You can like put the numbers and the x and the y-axis. So the amplitude is 4, means this value is 4, and this value here is minus 4. How I know it? By the amplitude. The amplitude is 4. Now the period is 2 pi over 3. This means this point here is 2 pi over 3. Now the question is, what is the value for here? And what is the value here? And what's the value here? So this one I call it P1. This call I call P2. This I call it P3. So to find the P1 is equal this divided by 4. 2 pi over 3 divided by 4. Why 4? Because we need 4 points. And this is equal 2 pi over 3 times 1 over 4. And this is equal 2 pi over 4 times 12. And this is pi over 6. So this point is pi over 6. Second things we have to know, the distance from here to here is the same like from here to here. And this from here to here is the same, and this from here to here. So this distance and this distance and this distance and this, all of them are equal. So this means the point number 2 is equal pi over 6 plus pi over 6. So B2 equal this distance, this, because it's actually B over 6 plus this. So B over 6 plus pi over 6, and this is equal to pi over 6. And this is pi over 3. So this is pi over 3. For the third step, third point, the same idea. equal pi over 6 plus pi over 6 plus pi over 6, and this is equal 3 plus 3 pi over 6 over like pi over 2. This point is equal pi over 2. So now I know the points b1, b2, b3, and this is b4, the first last one, and this is what I need. This is the graph for the function. This is the graph for the function for cosine 3x. Any question? The point here is pi over 6. The point here is pi over 3. The point is pi over 2. This point is 2 pi over 4. Any question? Okay, another example. The last example in this section. Example 2. Graph y equal 3 sine 2x minus pi over 2. Pi over 4. How can I graph this one? How can I graph this one? So first step, we have to make this one as a form y equal a sine k times x minus b. This means the coefficient of x must be equal 1. So the coefficient of x must be equal 1. How can I make it? So here I have to factor. What is the factor? What is the factor? So the factor is taken 2 outside, and so it will be like this: y equal 3 sine 2, and here the remaining is x minus pi over 2, pi minus over 4. So this has the same shape like this one: y equal a sine k times this. So my k is 2, my a is 3, my b is pi over 4, and now we're ready for graphing. So what's the amplitude? Amplitude is 3, the absolute value for 3. So it's 3. For the period,
It's just pi.
2 pi over 2 is pi, exactly. And the third one is the period and the horizontal shift. Here we have a horizontal shift. So this graph is shifted to the right or to the left. Because we have minus, this means we have to shift it to the right. So shift it to the right by unit pi over 4. Horizontal shifting to the right by pi over 4. So, and the last one is one complete period. The one complete period is the last one is from B. This is B pi over 4, comma, pi over 4 here, plus the period. The period is pi. Now we're ready for graphing. So first things, to graph these things, we have to hide the shifting. Put your hand here and hide it. I mean, like by hide it, like there is nothing here, for example, like this. Grab the function like this. Then after you grab the function like this, remove this one and grab this one. Let me change the color here, like this, here. So here. Right. So to graph this one, like graphing like this, exactly. After you graph this, you do the shift. So I'm going to graph. Here is the X, the Y, the X. The function is sine function. The graph for the sine function, something like this. Something like this. At 0, 0, goes up, goes down, goes up, like this. This 0, pi over 2, pi, 3 pi over 2, 2 pi. This is the first step. Here, the value is the amplitude. The amplitude is 3. So the value here is 3, and here is negative 3. How I know? By the amplitude. How I know? Because the amplitude is 3. So this value is negative 3, this value is 3. Now the horizontal, forget the horizontal. So this is the graph actually for, now the period. The period is pi. Here not 2 pi, something wrong, sorry. Here pi. So the period here is pi. Now this point is B1, this point is B2, this point is B3. So to find this point by this step, so B1 equal pi, this pi over 4. So this point is pi over 4. B1 is pi over 4. B2 actually is the same as spaced like from 0 to pi 1 to B1, and from B1 to B2. So it's equal pi over 4 plus pi over 4. And this is equal 2 pi over 4, and this is equal pi over 2. So this is pi over 2. B3, this B, is equal pi over 4 plus pi over 4 plus pi over 4. And this is equal 3 pi over 4. So this is 3 pi over 4. And this is pi, the period. So this is ready. The amplitude is ready, the period is ready. Now the horizontal shifting. Now I have to shift this function to the right by pi over 4. So all the points here, the function must be shifted to the right like this. Means I have to shift all these points to the right. To the right by what? By pi over 4. So the 0 here, when you shift it to the right, it's become pi over 4. The other point become pi over 2. So this is actually moving this function like this. Like this exactly. So this point is pi over 4. This point is pi over 2. This point is 3 pi over 4. This point is pi. And this point here is pi plus pi over 4. So pi plus pi over 4 is equal 4 pi plus pi over 4 and this is 5 pi over 4. So this point here is 5 pi over 4. This is 5 pi over 4. Any question? Any question? So this is the graph of y equal 3 sine 2 times x minus pi over 4. Anyone has a question? Is it clear? Is it clear how to graph? So by this example, we finish this section. And so after, like, if you do this example, I mean like example like this, you can do any example for this section. This example talk about amplitude, period, horizontal shift, one complete period. And this is the example we did. Also the same things for the example here, for this example. If you can do this example also, you will be fine. So now let's go to the new section, is the 5.5, the inverse trigonometric function. Okay, so here, and there are graphs. So now we're going to know how how is the inverse for the trigonometric functions. So in the first, the graph of the cosine function is look like this. I'm going to start for the cosine function. So the inverse of the cosine function, first of all. Here, starting for the inverse function, then I go to the cosine function. The inverse of the sine function. So first of all, like we learned, the graph of the sine function, something like this. At 0 is 0, goes up, goes down, goes up. And here can continue, but we don't need it. It's enough for period 2 pi. So this is the sine function, sine of t. This is the value for t. This is 5. Here is 1, and here is minus 1. Is the sine function is 1 to 1? Is this function is 1 to 1?
No.
How you know?
Because it fails a horizontal line test.
Yeah, the horizontal line test, look. That's true, William, thank you. This is the horizontal line. It doesn't pass the horizontal line. So the line, horizontal line, across the curve at 2 points, this point and this point. So this does not passing the horizontal line test. And also here, down at this point and at this point. So the horizontal line test does not pass. So how can I find inverse for the function if it's not 1 to 1? So the function is not 1 to 1. How they find the inverse for the function if it's not 1 to 1? The function is not 1 to 1, so I can't find inverse. So what they did, so to make this function has inverse, I'm going to continue this function from this side, like this. Because it's periodic function. Continue this function from here also. And I'm going to restrict the domain. I mean, I'm going to take this piece only from the function. Only this piece. From here to here. So this piece, I want to graph it here down to be like something like this. This is the piece, the red one. Now, if I check this function is 1 to 1, so I'm going to check, is this one function is 1 to 1, only this piece? As we see in the horizontal line test, it's passing the horizontal line test. At every point, it's passing the line at only one, intersect the line at only one point. So this means now this curve is passing the horizontal line test. This mean is 1 to 1. This mean it has inverse. So I'm going to take only this piece of the sine function. to find the inverse. So by the way, this point here is negative pi over 2. This is pi over 2. This point here is negative 1, and this point is 1. So here I can set the domain. What is the domain?
Negative pi over 2 to pi over 2.
From negative pi over 2 to 2 pi over 2. And what is the range?
Negative 1 to 1.
Yes, from negative 1 to 1. So the domain is from here to here, and the range from here to here. Now I can find the inverse for this one. So the inverse is gonna be something like this. First of all, let me give you the definition for the inverse. So since I find the piece that's work for the inverse, I can define the definition for inverse. I can find the inverse for the function. So here let me define it, sine t, such that t here I can set t between pi over 2. Here t is between pi over 2 and negative pi over 2 and pi over 2. Not all t's. So sine t between negative pi over 2 negative pi over 2 t and pi over 2. So the definition now for the inverse here, I can set the inverse of the sine function is the function sine inverse of x. The domain for the sine, the domain for the inverse function is the same as the range of the function. Like I said before, the domain is the range for the inverse, and the range is the domain for the function. The range for the function is the range is the domain for the inverse. So the domain for the inverse is the same as the range of the original function. So the domain is negative 1, 1, and the range is the domain for the function, this one, negative pi over 2 to pi over 2. Now I can define the inverse as sine inverse of x equal y. This means sine of y, sine of this one, y, equal x. This is my rules to find the inverse. Now by these things, I can graph the inverse function. So the graph would be something like this. From minus 1 to 1 is the domain. So here is minus 1, and this is 1. This is the domain. The range is from minus pi over 2 to pi over 2. So this is minus pi over 2, pi over 2 here, the positive. So here point, and here is another point. Okay. So the domain for the inverse is from minus 1 to 1. The range is from minus pi over 2 to pi over 2. Now this, the definition how to find the inverse, because I'm going to give you example after. Also, I'm going to to define the cancellation properties. So the cancellation properties, the last things for the sign is cancellation properties says sine of sine inverse of x is the same as x, but x here is between minus 1 and 1, and sine inverse of sine x is equal x. X here is between minus pi over 2 and pi over 2. By this, we finish from the inverse of the sine function. Again, sine inverse for the sine function, we have to take this piece only. So we have to restrict the domain. When I take this piece, I get the function one-to-one function. Now the domain for this one is from minus pi over 2 to pi over 2. The range is from minus 1 to 1. The inverse function, the domain is the range. The inverse function has range is the domain of for the sine of t. So the inverse function denoted by sine inverse. The domain of the sine inverse is from minus 1 to 1. The range is from minus pi over 2 to pi over 2. This is the formula how we can find evaluate. I'm going to give you example how to evaluate. So sine inverse of x equal y. This means sine of y equal x. The graph of the inverse will be something like this. From minus 1 to 1, and from the range from minus pi over 2 to pi over 2. Then I give you the cancellation properties. Sine of sine inverse is x, sine inverse of sine is x. But x here is different about x here. X here is supposed to be like the domain for the sine inverse. The domain for sine inverse is from minus 1 to 1. The domain for the sine is from minus pi over 2 to pi over 2. Now the cosine function, the same steps, same things. So the cosine function for the cosine function will be something like this. So I know the graph for the cosine function. Here. The inverse of the cosine function. By the way, the cosine function is not one-to-one function. Why? Because the graph for the cosine function like this is not passing the horizontal line test. Same things here. So this is the horizontal. This is the cosine function. So it doesn't passing the horizontal line test. Look, it passing the period for more than points. So to make this function is one-to-one, I have to restrict the domain. I have to take piece of the cosine function. So the best things I have to do here to restrict the domain is to take this period only. From here, goes down to here. This is the only period I have to take it to make the function is one-to-one. So the graph only for this piece is like this. Here goes down like this, stop here. This point is 1, here's 1, here's -1. This point is 1, this point is -1. This point is 0, pi over 2. And this point is pi. So this is the cosine function, y equal cosine of x between 0 and pi. So what is the domain for this function? What is the domain and what is the range?
Domain 0 to pi and range is -1 to 1.
Yes, from 0 to 2 pi, and from -1 to 1 is the range. But here, the domain is from -pi over 2 to pi over 2. The range is the same from -1 to 1. So now the same things, we have definition for the cosine function for the inverse. So definition. The inverse, here the inverse cosine function is the function cosine inverse of x. The domain, the same things. The domain for the inverse is from -1 to 1. And the range is from 0 to pi over 2, to pi. Because the range is the same like the domain, from 0 to pi. Okay, so how can I define it? This is the important things here, the cosine of inverse of x equal y. This means the cosine of y equal x. Same things here. Now, for the graph, of cosine inverse of x. So the graph for the cosine function will be something like this. Has a graph like that at 0, goes up like this, then stop here. So this point here is -1 to 1. This point is 0. This point is pi. Same things for the cancellation properties. The cancellation property said cosine of cosine inverse of x is x. Here x belongs to the domain for the cosine. The domain for the cosine is from -1 to 1. And the same thing is cosine inverse of cosine of x is x, such that x here belongs to the domain for cosine is negative. The domain for the cosine is from 0 to y. Okay, until here, everything is fine. Is it clear?
Mm-hmm.
What about the other student? Zishan and Angel. Is it clear until here for the inverse, the definition and the graph?
Yeah, yes, it's clear.
Okay, so now after all this, I'm going to give you example, and I'm going to show you how we can using this, the domain, the range, the steps here, the graphs. First example is evaluate. Okay, so 5 point. The question is evaluate sine inverse. Number 1, sine inverse of 1/2. Number 2, going to do it here. Sine inverse of -1/2. Number 3, sine inverse 3/2. So I'm going to do the first one step by step. The question is how to find the sine inverse of the 1/2. First step, you have to set 1/2. You have to check, is the 1/2 belong to the domain of sine inverse? The domain for the sine inverse here The domain for the sine inverse is from -1 to 1. You have to check, is the 1/2 belong to the -1 to 1? Yes, 1/2 is between -1 and 1. So the first step is good. Second step, using these properties. Sine inverse of x equal y, then sine of y equal x. So you said here sine inverse of 1/2 equal x. Now you need to find the values, or this is equivalent to sine of x equal 1/2. You ask yourself, what's the value for x? I mean, for x belong to the interval from -π/2 to π/2. This is the only interval I can use. What is the value for x belong to this interval? The answer for the sine is 1/2. If I plug it inside the sine, they give me 1/2. What is the value for x? If I plug it inside the function, they give me 1/2. Any idea? What is the sine? What's the value for x? If I plug it inside the sine, they give me 1/2. This is from previous section. Which value here, if I plug it inside the sine, they give me 1/2?
π/6.
X equal π/6. This is true. The π/6 is between this interval. If it's hard for you, graph a unit circle like this. Like this. You cannot know where is exactly the interval. This is unit circle. The interval are required is from here to here. This is my t. X is between -π/2. This is -π/2. And this is π/2. So x π/6 is here. Around here. It's π/6 here. So the value for x is π/6. For the first one, the value is π/6. For the second one, 2. So the same steps. Is the -1/2, this is for the first one. Number 2. Is -1/2 belong to the interval -1 and 1?
Yeah.
Yes, so it's correct. I can't find the value for the sine inverse for this value. So I can't find the value. So check, it's work. Now using the same properties, you said sine inverse of -1/2 equal x. This is mean sine of x equal -1/2. What is the value for x? If I plug it inside the function, they give me -1/2. Because the sign here is negative, this means the value must be in the fourth quadrant here. So what's the value for x? What is the t? Like x here distance, I mean. What is the value for the distance? If I plug inside the sign, they give me -1/2. Yes, the third quadrant is negative, but here the value must be between pi/2 and -pi/2. Why? Because the domain for the inverse, the domain of the inverse, here, the range of the inverse must be, like, I mean, the domain for the function must be between -pi/2 and pi/2. This is the domain for the value for the sine function. Must be here. That's why I have to restrict the domain. So that's why my question is, what is the value for x such that x between -pi/2 and pi/2? So x is the same like this one, pi/6, but is not in the first quadrant, it's in the fourth quadrant. So I have to go inverse back. So x will be -pi/6. So if I plug this one inside the sign, they give me -1/2. Clear? Any question? So this value here belongs to from -pi/2 and pi/2. Second one is clear. Third one, who will do the third one? Sine inverse of 3/2.
We can't do that one, right?
You cannot do that one because 3/2 is a block between -1 and 1. 3/2 is 1.5, is greater than 1. So it is not belong to this interval. So undefined, no values. Okay, so undefined, no values. We cannot find it. No inverse for the sign this. There is no inverse. Okay, another example. The example is if I find sine inverse of sine pi/3. Sine inverse of sine for pi/3. The quiz will start at 9:40. Find the sine inverse of sine of pi/3. Okay, I'm going to do this one.
Don't the sine inverse and sine just cancel each other? Yeah, 5/3.
Yeah, this is true, but you have to check first of all. You have to do it step by step because sometimes it doesn't work. First of all, you have to check, is pi/3 belong to the interval -pi/2 and pi/2? How I know this? By here. Cancellation property. Cancellation property said sine of sine inverse. We have to check sine inverse of sine. We have to check, is x, this x, between -pi/2 and pi/2? Because sometimes it doesn't work. Is it work? Is it plugged inside? So yes, it is inside. So if it is inside, using the cancellation properties, I can say this is equal by, so by using cancellation properties, by using cancellation properties, this is equal pi over 3.
So if it was like sine inverse of sine of 3/2, that we couldn't do that, right?
Yes,
Okay.
exactly.
Thank you. Thank you.
So second one, sine inverse of sine of 3 pi over 2. I'm not using 3 pi, I'm using 5 pi over 6. So 5 pi over 6 is not belong to interval from minus pi over 2 and pi over 2. So I cannot use cancellation property. So I have to use my way to check. Sine 5 pi over 6, so I have to do it manually without the cancellation property. What is the sine of pi over 5 pi over 6? So by using the previous section, we have to find the reference number for this one. The reference number for this one is in the second, and the sine. So the reference number for this one is pi over 6, and it's in the second quadrant, so the sign is positive. So it would be like positive sine pi over 6, and this is equal sine inverse of, what is sine pi over 6?
1/2.
1/2. Now, is the 1/2 between, now you have to ask yourself, is the 1/2 belong to the interval from -1 to 1, the domain for the sine inverse? Yes. So I can find the value. Now sine inverse for 1/2 is, so sine inverse for 1/2 is equal x. So sine of x equal 1/2. I have to find the value for x that belongs to the interval from pi over 2 and from negative pi over 2 and pi over 2. So like before, x equal pi over 6. So in this case, look, x equal, the value is pi over 6 is not equal 5 pi over 6. So here, that's why I cannot use the cancellation properties. If I want to use the cancellation properties, the answer will be like 5 pi over 6, and this is wrong, completely wrong. The answer is pi over 6. That's why you have to check before using the properties. You have to check, is the value is between negative pi over 2 and pi over 2, then you continue. Okay, so this is for the sine. I'm going to give you just one example or two examples before the class is end for the cosine, and the section will be finished. And next time we have a quiz for this for the previous section. I think for section 5.3 and this section. Example. Evaluate. Cosine inverse of the third root of 2. Second one is the cosine inverse of 0. Not 0, I'm not going to use 0. I'm going to use negative 1/2. Okay, for the first one, is the square, what's the domain for the cosine inverse? What is the domain for the cosine inverse? The cosine inverse here, the domain is from -1 to 1, and the range from 0 to pi. So is square root of 3 over 2 belong to the domain from -1 to 1? This value is this value belong to this interval?
Yeah.
Yes. So this means it has inverse. Now, using the properties, cosine inverse of square root of 3 over 2 equal x. This means cosine of x equals square root of 3 over 2. What is the value for x that belong to the interval from 0 to pi? And if I plug it here, they give me square root of 3 over 2. What is it? Pi over 6. Yes. Pi over 6. When I plug it inside the cosine, they give me the square root of 3 over 2. And pi over 6 is inside the domain of the cosine. So this is the value. For the second one, negative 1/2. You have to check, is negative 1/2 belong to the value from -1 to 1? Yes, negative 1/2 is belong to this value. So this means it has inverse, the same steps. So cosine inverse of negative 1/2 equal x. This means cosine of x equal negative 1/2. So what is the value for x that belong to the interval from 0 to pi? Such that if I plug it here, they give me negative 1/2. Because the cosine is negative, so it's supposed to be in the second quadrant. I mean, for the second quadrant, the graph will be something like this.
But there's a question, right?
Oh, yes. What is the value? So the value is between here,
It's 2 pi over 3.
2 pi over 3, exactly. So it's supposed to be in second quadrant because it's negative. So x equal 2 pi over 3. Why? Because in the second quadrant, like, you think like this, x bar, the reference is pi over 3. So x is supposed to be 2 pi over 3, like this thinking. So the x reference is pi over 3. And the second quadrant is 2 pi over 3. And this is the answer. Okay, everyone, we're going to stop up to here. Next quiz will cover all these sections. And by these things, we finish this section. Any question? Any question? Okay, if there is no question, get ready for the quiz. Will be on the web sign. Good luck. See you next time.